Hello, on this video I'm going to give you a brief introduction of the C#'s generic type. So for that, let's write some code. I'm going to open my Visual Studio and then I'm going to create a new project. I'm going to choose the console application and I'm going to name it GenericT. And now I'm going to create a class. So add a class and I'm going to name this generic test. Click on add and now I have a generic test class right here. Alright, so the generic, it's something that we use whenever we do not use a specific data type to accomplish a task. And by doing so, whatever code you create becomes more flexible because you can use with more than one data type. So if I come here and I create a function to print the smallest number between two parameters, I would write something like this. Now, from the main program, I would have to create an instance of that class. And then I would pass two numbers, 10 and 20. And this would work just fine. The function to print the 10. But what if I want to pass a float, for example? If I try to do that, it will fail. And the reason is because the print smallest requires a parameter to be exclusively integer. So if I try to pass floats, this is not going to work. The way to solve this problem is to create a different function that accepts the float, or you can create a generic function. So let's create the generic one first. So on the print smallest right here, in order for me to make it this generic, I would put a T here, and this T is for the generics. And then instead of an integer, I would put T here for the generics and T again. And doing so, this parameter now is a generic parameter. Now there's a problem here on the comparison. If I hover over, it says here that the operator less than cannot be applied on the generic types. So because of that, we need to use the comparable class here. So I'm going to type here where T is the system.iComparable. And now we can use the comparable to do this comparison here. So instead of doing A less than B, now I'm going to do A dot compare to and then compare to B. Now the compare method returns 1 if A is bigger than B. Then it's going to return 0 if A is equals to B. And then finally it's going to return -1 if A is smaller than B. So if I'm trying to get the smallest one here, I'm going to choose when this is equals to -1. So if the compare method returns -1, then I know that A is smaller than B. So now, from my main program, I can pass the same parameters as a float, and then it should print at 10.5. So it prints at 10.5. And now if I want to pass a integer, it also works just fine. So the advantage of using the generic type is that now with one method, you can accomplish the same work using different types of parameter. Alright, so let's write one more function right here. So let's write a method to swap. So public void swap, and then I'm gonna put a int A, int B. Create a temp here. So to swap, this is almost what you want to do with two integers. The problem right here is that if you call this method, it's not gonna swap. So let's test it. So here I have two integers, and then I'm gonna call the swap And I'm going to try to print x. So the expectation here is that after the swap, x would have 20, but it's not. So if I run, I still have x equals 10. And the problem is that when you call this method, you're passing these parameters here as value, not as a reference. That means this method is getting a copy of these two values. Therefore, the original value from your program does not get changed. To solve this problem, we're going to pass this as a reference. And now, instead of the value being passed, you pass a reference for that value. In other words, you're passing the address. And then when you call that function, you cannot call using the value. You need to pass a reference for that value. So I'm just going to put a reference here as well. And now when you call this method, you're actually passing the address of this variable, not the variable itself. So if I run this program now, I get x equals 20. So that means he actually did switch the two variables. But this doesn't solve the problem yet, because we want to be able to pass a float right here, and this float should work as well. But when I try to call, I have a problem, because it cannot convert these two different data types. So because of that, we're going to make this swap function here a generic type. And to make this into a generic type, right here on the name of the method, I'm going to put the t. And then instead of integer, I'm going to put the t here again. And instead of integer, I put the t one more time. And then when I'm creating a variable, I'm going to put the type t again. And by doing so, this swap method is now a generic one. So I'm going to go back to my main program. And now, as you can see, I can pass the x and y as floats. And this program is going to work just as well as it worked with integers. And if I want to put a decimal, and if I run this program, it works as well. So the whole point of using generic is that you can use a generic data type instead of a actual data type, and have your methods be very flexible, where you can use with different data types that you want to work with. All right, so that's all for this video. Thanks for watching. This is easy and you can do it.